In today's lesson, we are going to walk through a typical enthalpy of solution / hydration question found at A-level chemistry, advanced placement chemistry, and IB chemistry. This question is about magnesium chloride. Write the equation including state symbols for the process corresponding to the enthalpy of solution of magnesium chloride. So enthalpy of solution, delta H sol, is the enthalpy change when 1 mole of a compound dissolves in water to form an infinitely dilute solution under standard conditions. So in other words, it's just dissolving a salt basically in water. So magnesium chloride is the salt, so MgCl2 is S. Then you can write sort of AQ, aqua, over the top, and then that becomes magnesium 2 plus AQ to show that it's dissolved or solvated, plus 2Cl minus AQ. Use these data to calculate the standard enthalpy of solution of magnesium chloride. So I've covered this in another video where I describe how this equation, delta H sol, which is the solution, is equal to the hydration enthalpy minus the lattice enthalpy, ELE, right? So I go through the derivation of this equation in another video. So the link for that is in the description below. So for now, we're just going to use it, right? And plug the numbers in. So it wants the enthalpy of solution. So let's go ahead and do this. So we need the hydration enthalpies. So it'll be minus 1920 for magnesium. And there's 2 chlorides. So because it's MgCl2, so it'll be minus 364, minus 364, minus the lattice enthalpy, which is 2493. Now you have to be careful here. That's the lattice dissociation enthalpy, which is positive. This equation uses the lattice enthalpy, which is the enthalpy change when 1 mole of an ionic compound is formed from its ions. Now, in other words, it's the opposite of that process. It's not the dissociation, splitting the lattice back up. It's the enthalpy of bringing the ions together to make the lattice. So I have to remember, I have to read that as negative 2493. So putting that in. So just watch out for that. Exam questions can be like that. They'll do that. So the workings, negative 1920 gives me an answer of negative 155 kilojoules per mole. So what does that number tell me? It tells me that when you put magnesium chloride into water, it dissolves very easily, very readily, because it's exothermic, right? So this is an exothermic process. So generally, salts that have exothermic enthalpy of solutions, they dissolve readily. They dissolve at room temperature. Solubility is the measure of how much of a substance can be dissolved in water to make a saturated solution. A salt solution is saturated when an undissolved solid is in equilibrium with its ions. Use your answer to part B to deduce how the solubility of MgCl2 changes as the temperature increases. So let's rewrite the equation. So MgCl2S goes to Mg2 plus 2Cl minus. We're told now we can treat it as an equilibrium, so it's reversible. And I've just determined that the forwards process, actually let's write the R underneath, the forwards process is exothermic. So delta H is negative VE. That means exothermic. If I increase the temperature of this equilibrium, what's the equilibrium? It's all of it. The position of equilibrium will move to oppose the change as much as possible. So increasing the temperature would cause the equilibrium to move to oppose the change. So it's going to move in the direction which is going to absorb the heat, which is the endothermic direction. So let's formulate the answer. Increasing the temperature would drive EQM, the equilibrium, to the left. Bullet point 2. Why is this? The reason why is because that's the endothermic direction, and the endothermic direction will absorb the heat. So that means if the equilibrium is moving from the right, where the aqueous ions are, to the left, where the solid is, and you're going to produce more solid the higher the temperature goes because it's moving to the left, we can therefore conclude that the solubility in this particular instance decreases. So therefore, the solubility decreases for MgCl2 as the temp increases. Now, that is just for magnesium chloride. It could be different for sodium chloride. It could be different for potassium sulfate. You've got to take it on a case-by-case basis, and it's all to do with this equation. This determines the enthalpy of solution, and as soon as you have that number in front of you, then you can talk about the solubility in terms of whether the temperature increases or decreases and how that affects the solubility. Will more dissolve or will less dissolve? In this case, less is going to dissolve because the equilibrium will shift to the left. Right, that's it. I hope that was helpful. Check out the other videos on this topic below, as well as its links to sort of entropy and Born-Haber cycles. They're often mixed as like one big question at A level. It's very common for that. And thanks for watching.